Let us now apply different properties of logarithm that we have learned in our previous discussion. So in here, we are asked to expand each of the logarithms. So our first problem is this. Logarithm of 6 times 11, log of 6 times 11. So using the product rule, this will be equal to the log of 6 plus the log of 11. For problem number 2, we have the log of 6 over 11 raised to the power of 5. Now applying the power rule, no? Because we have this exponent here, so this will become 5 and the log of 6 over 11. But then since 6 over 11, the log of 6 over 11, we have to apply the quotient rule to be able to expand it. So how are we going to do it? So this is now equal to 5 times the log of 6 minus the log of 11. So our final answer would be distributing 5 to each term. It will become to log 5 log of 6 minus 5 log of 11. So this is our final answer. We have our third problem here wherein we are asked to expand the logarithm of the cube root of x, y, and z. So this is now equal to, let's remove first the radical sign. So this is equal to the log of x, y, and z raised to the power of 1/3. It is because this is cube root. Okay, so applying the power rule, it is now 1/3 multiplied to the logarithm of x, y, and z. So in here, we're going to apply the product rule. So this is now equal to 1/3 times the log of x plus the log of y plus the log of z. Okay, now let's distribute the 1/3 to each of the terms. So this is now equal to the log of x over 3 plus log of y over 3 plus the log of z over 3. This is now our final answer. So I think it is now clear to you on how to expand a logarithm using its properties. We're gonna proceed now on how to condense an expression into a single logarithm. So we have here an example. Okay, so log 3 minus log 8. We are asked to condense this expression into a single logarithm. So as we can see, this is subtraction. So therefore, this comes from the quotient rule. So therefore, applying property number 6, this is now equal to the log of 3 over 8. In number 2, we have this expression, log of 6 all over 3. Right? It is not log of 6 over 3, but a logarithm of 6 divided by 3. So how are we going to express this expression into a single logarithm? Okay? Now, since this is over 3, it is equal to 1/3 the log of 6. Now, property number 7, the power rule. So this is equal now to the log of 6 raised to the power of 1/3. Okay, so therefore, this is the logarithm of the cube root of 6. Our third problem is this: 4 multiplied to the logarithm of 3 minus 4 log 8. Now, applying property number 7, which is the power rule, this number here becomes now the exponent, okay, as well as of this. So this is now equal to the log of 3 raised to the power of 4 minus the log of 8 raised to the power 4. Now, since this is subtraction, then we can apply the quotient rule. So it is now equal to the log of 3 to the 4 over 8 to the 4th. So we now have a single logarithm coming from this expression. In our fourth expression, we have this: the log of 2 plus the log of 11 plus the log of 7. Since this is all in addition, therefore, we're going to apply the product rule. So what will happen? This is now equal to the log of 2 times 11 times 7. Okay, so multiplying 2 times 11 times 7, it is now equal to the logarithm of 154. So we now have a single logarithm from this expression. For our fifth example, we have this expression here, wherein we are asked again to condense it into a single logarithm. We have 4 log a base 3 plus 6 log b base 3. So what we're gonna do here? So we have to apply the power rule, wherein this will be equal to the log of 8 raised to the power of 4 base 3 plus the log of b raised to the power of 6 base 3. Okay, now since they are in addition and the logarithm have the same basis, which is equal to 3, therefore we can combine them, okay, applying the product rule. So this is now equal to logarithm of a to the 4th b to the 6th base 3. So we now have a single logarithm out of this expression. In problem number 6, we have this expression: the log of x base 4 minus 6 log of y base 4, and we are asked again to condense this expression into a single logarithm. Okay, so we have to simplify this one first. Okay, so it will become the log of x minus 4 minus, applying the power rule, the log of y raised to the power of 6 base 4. Now, since this is subtraction, therefore we're going to use the property number 6, which is the quotient rule. And since they have same bases, then we can combine them. It is now equal to the log of x over y raised to the power of 6 base 4. So this is now our final answer. We now have a single logarithm from this expression. Let us now apply further our knowledge on logarithmic expressions by solving some logarithmic equations. Here, in our problem number 1, we are asked to find the value of x in this equation. Logarithm of x base 3 plus log 2 base 10 is equal to log of 18 base 3. As you can see, we have addition here now. Therefore, we're going to apply the product rule so that we can condense this expression into a single logarithm. So this is now equal to the log of 2x base 3 for these two expressions. Okay, it's x times 2. Okay, it's 2x base 3. Okay, that is equal to the log of 18 base 3. Okay, we can eliminate this one already. So therefore, what remains? We have 2x is equal to 18. Dividing both sides by 2. Divided by 2. So let's eliminate 2. X now is equal to 9. We have here another equation. Log of x squared base 8 is equal to log of 4 base 8 plus log of x minus 1 base 8, and we are asked to find for the value of x. Okay, so let's solve this one. This is now equal to the log of x squared base 8 is equal to, so you can see, this addition. So this is the expansion of the product rule. So we have to condense this to form one single logarithm. So this is equal now to the logarithm of 4 multiplied by x minus 1 base 8. Okay, so let's simplify it. This is equal to the log of x squared base 8 is equal to the log of 4x minus 4 base 8. Now we can eliminate already this, and we now have x squared is equal to 4x minus 4. Okay, so we can have a quadratic equation. This is now equal to x squared minus 4x plus 4 is equal to 0. Now factoring this out, it is equal to x minus 2 squared. So therefore, you can say from this expression, that is x minus 2 is equal to 0. So our x now is equal to 2. For our example number 3, we have this given. Log of 3x base 5 is equal to log of 24x base 5 minus log to 4x base 5, and we are asked to find for the value of x. Okay, as you can see, we have here subtraction. So this is the expansion of the quotient rule. Okay, property number 6. So we have to condense this expression into a single logarithm. Okay, so it is now equal to log of 3x base 5 is equal to the log of 24x over for x base 5. In here, we can already eliminate x, okay? And then we have 24 divided by 4, which is equal to 6. So therefore, it is now equal to log of 3x base 5 equals log of 6 base 5. Eliminating the logarithm. So we can, this now equal to 3x is equal to 6. Let's divide 3 on both sides. So eliminate 3. So x now is equal to 2. We now proceed to example number 4. Okay, we are asked to find for the value of x in this logarithmic equation, which is log of x squared base 3 equals 8. Okay, applying the power rule, property number 7, this is now equal to 2 log of x base 3 equals 8. Okay, so let's divide both sides by 2. So we can already eliminate 2 here. And what remains, we have the log of x base 3 is equal now to 4. Okay, so how are we going to eliminate the logarithm? So applying the property number 4 in our previous discussion, this is now equal to 3. And we have to make this as an exponent. Okay, log of x base 3, and also write here 3 raised to the power of 4. Okay, from the property number 4 in our previous discussion, 3 log raised to the power of log of x base 3 is equal to x. Okay, so therefore the logarithm is already eliminated, and x now is equal to 3 raised to the power of 34. Okay, so simplifying it, x now is equal to 81. We have here another example. Logarithm of 1000 base x is equal to 3. So we are asked to find the value of x. Okay, so again, let's apply here property number 4. Okay, so since our base here is equal to x, so we have now x raised to the power of log of 1000 base x is equal to x raised to the power of 3. Okay, so we can now eliminate the logarithm from the property number 4. This is equal to 1000 is equal to x to the power of 3. So therefore, to find for the value of x, it is now equal to x is equal now to the cube root of 1000. Okay, and the cube root of 1000 is equal to 10. So x now is equal to 10.